see an example. Using the Gram-Smith orthogonalization process, compute the first three orthogonal polynomials P0 of x, P1 of x and P2 of x, which are orthogonal on interval 0, 1 with respect to the weight function w of x equals to 1. So solution for this, whatever we have given, so w of x equals to 1, and we know that the initial approximation, that is phi naught star of x equals to 1. So from this what we will get is p naught of x equals to phi naught star of x, so which is equal to 1. So this is the value of p naught of x, so it is phi naught star of x, which is equal to 1. Next one is p1 of x. So p1 of x, the value for this is x minus a10 phi naught star of x. So for this we need to find value of a10. So to calculate a10, we have the formula integral a to b. So here our interval is from 0 to 1, so integral over 0 to 1 x into w of x dx upon integral 0 to 1 w of x dx. Okay, so now our weight function is w of x is given as 1, so directly we have integral 0 to 1 x dx upon integral 0 to 1 dx, which is equal to again x square upon 2 over 0 to 1 upon x 0 to 1. So substituting its value, we have 1 by 2 upon 1, which is equal to 1 by 2. So the value for a10 is 1 by 2. So substituting the values of a10 in this equation, we get p1 of x equals to x minus 1 by 2 into phi naught star of x. We have the initial approximation as 1, so into 1, which is equal to x minus 1 by 2, and this value, whatever we have got, this is our phi 1 star of x. Okay, so now we need to find the value of p2 of x. So again, value of p2 of x is x square minus a20 pi naught star of x minus a21 phi 1 star of x. So we know the value of phi naught star of x as 1, and we need to find a20 and a21. So again by formula we have a20 equals to integral 0 to 1 x square w of x dx upon integral 0 to 1 w of x dx. So we got this as integral 0 to 1 x square dx upon integral 0 to 1 dx by substituting the value of w of x as 1. So this will give you again x cube upon 3 over 0 to 1 upon x 0 to 1, which is equal to 1 by 3. So we got the value of a20 as 1 by 3. So a20 is equal to 1 by 3. So now similarly we will have to find value of 8 to 1. So now to find the value of 8 to 1, which is equal to integral 0 to 1 x square into w of x phi 1 star of x dx upon integral 0 to 1 w of x into phi 1 star square of x dx. So in the notes I have not written x square, so you have to correct that, and then substituting its value, integral 0 to 1 x square into w of x is equal to 1, and phi 1 star of x we have found it as x minus 1 by 2 into dx upon integral 0 to 1 w of x as 1, so phi 1 star square dx as x minus 1 by 2 whole square dx. So we need to find the value of this. So we have integral 0 to 1 x cube minus x square by 2 dx upon integral 0 to 1 x square minus x plus 1 by 4 dx, which is equal to x raised to 4 upon 4 minus x cube upon 6 from 0 to 1 upon x cube upon 3 minus x square upon 2 plus 1 by 4x from 0 to 1. So substituting its value, it is 1 by 4 minus 1 by 6 upon 1 by 3 minus 1 by 2 plus 1 by 4. So this becomes 1 by 12 upon 1 by 12, which is equal to 1. So our value for A21 is 1. So the value of P2 of x equals to x square minus x plus 1 by 6. This is the final value for P2 of x. So similarly you have to find, you have to go through various books, numerical analysis by S. Chand and everything. So to get more problems on this. Good morning everyone. So today in this video we are going to see one new concept, that is Chebyshev polynomial. So what are this Chebyshev polynomial? So where do they come from? So for this you need to go back to trigonometry. You need to recall some trigonometric identities for this. So let us consider one trigonometric identity, that is cos 2 theta. Okay, so this cos 2 theta, which is equal to 2 cos square theta minus 1. Okay, so this is a basic trigonometric identity. Again cos 3 theta, which is equal to 4 cos cube theta minus 3 cos theta. Okay, so now we need to have formula for cos 4 theta. So for this we have to use this cos 2 theta formula. So cos 4 theta can be written as cos 2 into 2 theta. Okay, so now this we know that cos 2 theta is 2 cos square theta minus 1. So for this value we have 2 cos square 2 theta minus 1. Okay, so I have just substituted, instead of theta I have written 2 theta. So this is the value. Now we again know that cos 2 theta is this entire equation. So cos square 2 theta will be square of this entire equation. So we have 2 into 2 cos square theta minus 1 and this minus 1 as it is, and we have to make the square of this. Okay, so this is the value for cos 4 theta. Okay, now we can expand this cos 4 theta a little bit more, but what we are observing this cos 2 theta, cos 3 theta, cos 4 theta, that means cos n theta for any value of n, they can all be written as some polynomial in terms of cos theta. So cos 2 theta is cos square theta minus 1, cos 3 theta is 4 cos cube theta minus 3 cos theta, cos 4 theta is 2 into 2 cos square theta minus 1 whole square minus 1. So cos n theta can be written in terms of cos theta. Okay. So what we can say is cos n theta can be written as a polynomial in cos theta. So let us take one example. So let cos n theta can be written as Tn of cos theta. Okay. So what is this? So let us take one example. So suppose T2 of x. Instead of cos theta, I have written as x, and for n, I have taken value as 2. So 2 means it is cos 2 theta. So value for cos 2 theta is 2 cos square theta minus 1. So what we have is cos 2 theta equals to 2 cos square theta minus 1, and for T2x, where x is this your cos theta and 2 is your value for n, T2 of x can be written as, instead of cos theta we have to replace it with x, so 2x square minus 1. So you got one new polynomial, that is T2 of x, which is equal to 2x square minus 1. Okay. Similarly, for n equals to 3, that is T3 of x. So to find this T3 of x, we need to have value for n equals to 1 is cos 3 theta, which is equal to 4 cos cube theta minus 3 cos theta. So what we have going to do is 3x equals to 3x equals to 4. Instead of cos theta we can write x, so x cube minus 3 cos theta as x. So this is your next polynomial, that is T3 of x equals to 4x cube minus 3x. So there is a sequence of T0, T1, T2, T3 up to so on, such that in place of x we can write cos theta. So what we have is Tn of x, which is equal to cos of n theta. So if we have this, then we can find the values of T1 of x, which is equal to cos of theta, and we know that cos of theta equals to x. Similarly, T2 of x. So T2 of x, which is equal to, we'll get cos 2 theta. Now T0 of x will be equal to cos of 0, which is equal to 1. Okay. Now we will have to consider one identity, that is trigonometric identity, cos of n minus 1 theta plus cos of n plus 1 theta. It is like cos A plus cos B. So we have the formula as 2 into cos of A plus B by 2 into cos of A minus B by 2. So A plus B by 2 will get us n theta minus theta plus n theta plus theta by 2 into cos of n theta minus theta minus n theta minus theta upon 2. Okay. So solving this will get 2 into cos of 2n theta upon 2 into cos of minus 2 theta upon 2, which is equal to 2 cos of n theta into cos of theta, because cos of minus theta is theta, because cos is an even function. So we got this. So with the help of this, that is cos of n minus 1 theta plus cos of n plus 1 theta, we get one relation of Tn of x, that is this with in place of this we can substitute as Tn minus 1 of x plus Tn plus 1 of x, which is equal to 2 Tn of x into cos theta is again our x. So we got this relation, so we can rearrange this and we get Tn plus 1 of x equals to, so 2 into Tn of x into x minus Tn minus 1 of x. So this is in the form of a recurrence relation, so we can use it, we can use this to successively compute all the values of Tn of x. So we will see few values of Tn of x. So as we have seen, T naught of x equals to 1, T2 of x equals to, we'll calculate, so T2 of x, which is equal to, we'll get as 2x square minus 1. T3 of x will be equal to 4x cube minus 3x. T4 of x will be equal to 8x raised to 4 minus 8x square plus 1. T raised to 5 of T5 of x equals to 16x raised to 5 minus 20x cube plus 5 of x. So using this recurrence relation, we can compute all the values of T2, T3, T4 up to so on of x, whatever we need. Okay. So now we will express the powers of x, that is x raised to 0, that is 1. This can be written as T naught of x. Then power of x with respect to 1, that is x equals to, we know that it is equal to T1 of x. X square equals to 1 by 2 into T naught of x plus T2 of x. Similarly, x cube will be equal to 1 upon 4 into 3 T1 of x plus T3x. Similarly, x raised to 4 can be written as 1 upon 8 into 3 T naught x plus 4 T2x plus T4x. Okay, so x raised to 5 can be written as 1 upon 16 into 10 T1x plus 5 T3x plus T5x. And x raised to 6 can be written as 1 upon 32 into 10 T naught x plus 15 T2x plus 6 T4x plus T6x. So these are the values for the power of x. So with the help of this, we are going to solve further examples. So let's see one example. So find the lowest order approximation to the cubic x cube plus 3x square using the relation given above. So whatever the relations has been given, you have to write 2x cube plus 3x square. So 2 and instead of x cube, what we can write is 1 upon 4 into 3t1x plus t3x. So 2 upon 4 3t1x plus t3x plus, instead of 3x square, so 3x square as it is, because we are going to lower it, so we have to reduce it from cubic to quadratic form. So you can keep x square term as it is. So then 1 upon 2 into 3t1x plus t cube x plus 3x square. So this will give you 3x square plus 3 by 2 t1x plus 1 by 2 t3x. Now when you get this, we know the values of t1x and t3x. So we'll get 3x square plus 3 upon 2. Instead of t1x, we can directly write x plus 1 upon 2 t3 of x as it is. So if you look at this equation, you will get 3x square plus 3 by 2x plus 1 by 2 t cube x, and in this part 3x square plus 3 by 2x is the required lowest order approximation. Now what about this 1 by 2 t3x? So whatever the coefficient of t3x is, this is considered as the error in the approximation. We need to exclude this t3x, and the coefficient of this is known as error. So what we can conclude is this 3x square plus 3 by 2x is the required lower order approximation of the given cubic equation. Okay, and the maximum error in this equation is given as 1 by 2. Okay, so now we'll see the next equation or the next example. Express the following as polynomial in x. So we have to just express the following as polynomial in x. So what is given is t naught of x plus 2t1 of x plus t2 of x. So as we know that t naught of x can be written as 1, t1 of x is x, and t2 of x is nothing but 2x square minus 1. So just substituting these values, we will get t naught of x plus 2t1 of x plus t2 of x equals to, so 1 plus 2 into x plus 2x square minus 1. So we can reduce it to get 2x plus 2x square, and we can take this 2x common, so 1 plus x inside the bracket. So this is our required polynomial in x. Similarly, we can see the second one, 2 t naught x minus 1 upon 4 t2x plus 1 upon 8 t4x. So what we know that is value of t naught is 1. This is equals to 1, and t2 is equals to, this can be written as 2x square minus 1. Okay, now what we want to find is t4. So if you can by heart the value of t4, or else you can derive it with the help of t2, t3. because we know that it is a recurrence relation. So we know what's the recurrence relation. Tn plus 1 of x equals to 2x into Tn of x minus Tn minus 1 of x. So with the help of this you can find the values. So first of all we need to find T3 of x. So T3 of x can be written as 2x into T2 of x minus T1 of x. So substituting the values of T2x and T1x, we will get 2x into 2x square minus 1 minus x. So T3 of x is nothing but 4x cube minus 2x minus x, which is equal to 4x cube minus 3x. So this is the value for T3x. Similarly, we can calculate for T4x, which is equal to 8x raised to 4 minus 8x square plus 1. Okay, now we need to substitute all this equation, all the values of this T1, T2, T3, T4 and T0 in the required equation. So solving this, we'll get 2 T0 x minus 1 by 4 T2x plus 1 by 8 T4x, which is equal to 2 into 1 minus 1 by 4 into T2 of x is nothing but 2x square minus 1 plus 1 by 8 into T4 of x, which is 8x raised to 4 minus 8x square plus 1, which is equal to 2 minus 1 by 2x square plus 1 by 4 plus x raised to 4 minus x square plus 1 by 8. So this will finally give you x raised to 4, then minus 3 by 2 x square plus 19 by 8. So this is the required answer. So let's see few more examples. Express the following polynomials as sum of Chebyshev polynomial. So let's see the first example. 1 plus x minus x square plus x cube. So we know that 1 can be written as T0 of x plus x can be written as T1 of x. It is very simple. Now how can we write x square? We know that the power of x can be written as x square can be written as 1 by 2 into T0 of x plus T2 of x plus x cube can be written as 1 by 4 into 3 T1 of x plus T3 of x. Okay, so solving this you'll get T0 of x minus 1 by 2 T0 of x, taking T0 terms one side, so T0 plus T1x plus 3 by 4 T1x minus 1 by 2 T2x plus 1 by 4 T3x, which is equal to 1 by 2 T0x plus, so T1x plus 3 by 4 T1x, this will give us 7 by 4 T1x minus 1 by 2 T2x plus 1 by 4 t3x. So you can keep it as it is, or else you can take 1 by 4 common. So what we'll get is 2t0x plus 7t1x minus 2t2x plus t3x. On the similar basis, you can see a few more examples in the notes, and you can follow that.